Hello, everyone. Good afternoon. Thanks for joining our webinar today. And I'm Jerry from Cybernet. And today I want to share about what's happening in the vehicle industry right now and how we can use system level simulation to help make your life a lot easier. So here's is the plan for the next 20 minutes. And first, we will look at the big paradigm shift that everyone's talking about. Basically, is how vehicle development is changing with shift left and shift right. Then I will show you how to stay competitive using digital tools. And after that, we will talk about car theme, where it fits in your workflow, and some real world examples. And finally, I will quickly introduce what we do at Fabrinet and also the service we provide. And all right, let's get started. And I want to start off with these two charts. And the light, on the right side shows the when the car actually start production. So this is the start of production. And if you look at the new challenger car manufacturer or the EV startup in China, uh, you, you can find that they are moving very fast. Right. How they do it? They use any strategy. They use vertical integration and change their supply chain strategy and focus on fewer product variation. But the one I want to highlight today is the digitalization. They use virtual validation for everything. And traditional traditional car company, they usually take 4 to 5 years to make a car. And this new challenger that you can find that do it in 2 to 3 years, and that's 20 months to 30 months shorter. And this is not future. This is already happening. So if you want to stay in the game, the old rule is just don't apply anymore. And it is not about just being fast. And uh, the cars today are basically computer on wheels. So we got ADAS, we got self-driving, we got EV, self-defined features, and everything that has to work with each other perfectly. So the challenge is how we handle this complexity and launch the car faster, and most importantly, to not compromising the safety. So you can just skip the testing to save time. And so that's where the shift left and shift right comes in. And think of the gray part is the traditional V model. And now look at the new situation, the black part. That shift left means we start validation earlier and don't wait for the hardware. If you use model to test everything while the hardware is still being built. And shift right means keep validating forever. Since our vehicles are now software driven, so companies they launched it with the most must-have safety feature first, then push new feature later via OTA update. So to do this, you need a virtual proving ground, and that is a digital environment where you can test software updates uh, automatically before they reach to the customer. Okay, so let's talk about shifted by digital engineering and early validation. Uh, for OEMs, now they want models of subsystems before they buy them. Why? Because they want to plug your model into their virtual car to see if the performance is okay. So if you they wait for your hardware finished and then found the bug, uh, that's too late. So it costs way more uh, to fixing later. And for suppliers that think of systems levels model as your virtual demo. You can show them, you can show it to OEMs and how my system perform on your specific vehicle model, and also about SEOOC, which means safety elements out of context. And uh, in our uh, experience, that a lot of time OEMs sometimes are not even 100% sure what the spec they want. So or they want to build a quick uh, prototype or proof of concept. So as a supplier, uh, we often have to design something that the requirements are still very blurry. So if you having a simulation environment like CarSim, let you test your own assumption and prove your product works even if the spec aren't finalized yet. Okay, then uh, next is shift right by continuous validation. And here we are software-defined vehicle error. And nowadays, uh, vehicle's value is defined by its software. And to get to the market fast, uh, OEMs launch the base car and then add feature over time. And this where the digital twins come in. You use a system level simulator as a scenario generator, and you basically create a 24/7 digital test track to keep checking if the new software update break anything. So it's all about continuous safety. Okay, and now let's talk about our tools, Carson. That I'm not going to uh, go dive in very deep detail about the software, but I will talk about how and why the people use it. And Carson is basically the gold standard for vehicle dynamics, and you can think of it is full of math and physics equation uh, that Carson has done that has been verified for decades. So you don't need to derive the equation by yourself or holding the model by yourself. Carson has done it for you. So you just put it the vehicle parameters, the weight, the tire, the suspension, and set up a testing scenario. And you can hit run the math, and you can analyze the result. Here's is just a few examples for crossing that you can do EV or ADAS testing for application. And carving act as a common language between OEMs and the suppliers. For the OEM, it is a tool to figure out what they want. They play with the parameters until they find the perfect setup, and then they tell the supplier that this is the spec we need. And for the supplier, you take your component design and link into with parsing and prove it the performance hit those specs and the requirement. So this is what we call virtual sign off. That you send the OEMs your model and the system level simulation result as a digital uh, delivery. So it is basically saying that here's the proof that our product is work perfectly in your vehicle. Okay, so if we look at the development cycle again, that on the left side, casting is great for design optimization. That instead of manually change numbers and try and error, you can link casting to tools like Optimus in noises or some open source tools like uh, Optuna. And you let the computers runs like 500 tests overnight to find the perfect setup for you, not just manually doing it by yourself. And on the right side, that Carson is the automated testing engine that you can set up a pipeline where every time a programmer change a line of the a code, and you can trigger the Carson to automatically run like 50 standard of testing scenario to make sure the car don't make sure the software don't crash. Okay, so I want to uh, say is that your models are your digital asset. That they are not just uh, uh, they are not just tools. They are as valuable as your product, uh, which uh, basically they represent your product. And also the most important things that I uh, I want to talk about at the end is the data that this model and the infrastructure, including the test equipment, the test item, the automation pipeline, is including in this infrastructure. And beyond that, the most important thing is the data they produce. That uh, all these simulation and testing produce data, and what does it matters? think of some investing in the stock market that you always wish you can start 10 years earlier. Okay, so let's see some real world example first. The first one is Euro NCAP test series that uh, usually testing ACC is a lot of work, but in car scene, you don't just run uh, one test. Uh, you can use the built-in script language to run the entire Euro NCAP uh, ACC series. So you can programmatically try different speed, different distance, and even the script can calculating the score that your controller get uh, your controller achieve. So it's very simple, but it saves a huge amount of time and give you all the physical signal data you need for your report. Okay, uh, this is a second case that, uh, like I said, start doing triangle error manually by yourself. Uh, we can integrate carsins in SDK with some Python's tools or some third-party tools. In this case, we use Python's tool called Optima to optimize the regenerative braking power. And we told the Optima, uh, I want the vehicle slow down and average negative 0.2 G when I got off the throttle, and Optima will run 20 tests by itself. In this case, I just make it run 20 iteration. But if you need more, you can state a higher number. And it will shifting the parameter each time and found the answer. And it even show you some chart which factors actually matters if you have very multi-factors systems or cases. So it is much smarter and easier to than doing it manually. Okay. And this is the last example that uh, ISO 26262 for injection. In this case, we are testing lane keeping assistance system, and we assume it LCOD system. So safety is very is huge. So in the end, we need to test it with Howard in the loop test, and at a specific moment during the simulation, we modify the sensors data to simulate the sensor's fault, and we give it a wrong value. Then we watch that if the controller catch the arrow, does the car stay on the road, and this is how we prove our safety goals are met before we ever hit a real test track. Okay, So I want to introduce some about Cybernet Group that we started in Japan back in 1985, and we are all over the world now. And in Asia, we have a division in Taiwan, China, Malaysia, and we don't just sell software. We are specializing in building the various infrastructure for simulation, for testing, for some automation pipeline. So our goal isn't just give you a tools. Uh, we wish to provide you a solution that actually fix your specific problem. And uh, this is uh, our expertise that we specialize in various simulation. Uh, uh, yeah, we specialize in various simulation and testing or DMV, CAE tools. And we have done a lot of stuff for our customer that here is Hill, Hurry in the Loop setup for steering, and also this is for EPAs, and also Hill for AEB, and also Hurry in the Loop setup specifically for a self-driving vehicle that we link parsing with uh, Unreal Engine uh, for open source simulator Kala, and so that we can simulate that high realistic uh, camera sensor data, and also 6 degree of freedom driving simulators. And we also have built a data log for e-bus to monitor the electric bus remotely. And also this is what uh, we also help our customer to build the prototype or the lab card for them. Okay, so I want to finish our presentation with this slide that the old way, the traditional development ways is that we design and we run the simulation and we analyze the result. Then we modify the parameters and we simulation again. And this is uh, always, yeah. So uh, uh, now we are here that we use digital engineering to help our process that we should actually achieve that simulation driven design that uh, we use tools help us to find the best result for us and not just we try and error. And in this uh, method that we shorten the development time by 30, 33%. And remember that I said why data is the most important. That because I think it is easy to imagine that the future is AI assist design. So AI need data to learn. So no data, no AI. And uh, so the future is that we involve AI in the development process. So we wish or we assume that that can help us further shorten the development uh, cycle further by uh, 50%. And like I said about investing, that the best time to start was yesterday. So uh, you always think that you want invest uh, uh, earlier. So let these models to start generating uh, variable data for your now. Okay, so I think that's all from me today, and I hope this give you a better idea how carsing and digital engineering can help you move faster in your daily workflow. And if you have any questions, that feel free to ask. And here's also see our contact info and the website on the slide. And thank you for listening. Thank you.